2, 1.
Good afternoon, everyone. As you see on the screen, my name is Gary Rolfson. I'm the Director of Sales at StepCG. I'm actually joined today by Brooke Moore with Extreme Networks and Ben Jenkins at Cradlepoint. And we're really here to talk to you over the next 45 minutes or so about how the right partnerships with 5G and Wi-Fi create a comprehensive solution for connectivity for an entire campus of learning. Please, any questions that you might have, feel free to include those in the chat. We can either address those as they come up. We have someone manning the chat window, or we will address them at the conclusion of the presentation. But please, we mean this to be interactive and engaging. So if you have questions, we welcome them. As well as another housekeeping note. We will be providing copies of this presentation to you, as well as this conversation is being recorded. And so we will work with your individual partners out there, and we will get those out to you very shortly after the conclusion of today's talk. So with further ado, I will go ahead and I'm just going to start real quick and tell you a little bit about who StepCG is and how we fit into this equation between our two fine partners at Extreme and Cradlepoint. If there's two things that you take away from the conversation today and learning about StepCG, it is one, the folks that we choose to partner with and the resources that we can bring to bear from an end-to-end solution in terms of solving, the challenges of 21st century learning environments. So the folks at Extreme, the folks at Cradlepoint, we bring with that a broad knowledge that is comprised of a deep technical talent here at StepCG. As a matter of fact, we're about a 100-person company today. Well over 60 of those resources are technical in nature. Those are solution engineers, principal network architects. These are folks that man our network operations center and assist in our managed services, and folks that are out in the field every day, implementing and solving challenges and problems in your all's environment. Above and beyond that, a good deal of our talent inside StepCG comes directly out of the education space. As a matter of fact, about half of our revenue in a given year comes from solving the challenges in higher ed as well as K-12 and other 21st century learning environments. And so we feel like we've got a really good handle on that, as well as some expertise that we can bring to bear that really solves a lot of the challenges with a variety of solutions and approaches. We are one of the few companies that maintains, a deep technical expertise everywhere from your traditional 4 and 5G public cellular networks, even private LTE and private cellular networks, as well as your traditional layer 2, layer 3 networking, everything from, edge switching, access points, data center, core, etc., as well as our growing security practice. So not only can we take, all of these various solutions and mold them together, into one end-to-end offering, but we can take that all the way from, and we do this on a daily basis, all the way from, understanding an environment, addressing challenges or directions that, organizations want to go, through the design, even the implementation, and then after the fact, wrapping that in a very flexible managed service offering. A number, especially in today's learning environments, what we've seen is a number of our customers have gone from hundreds of devices to thousands of devices to tens of thousands of devices. One location to many locations, with students, remote learning certainly growing over time, and so they didn't get a whole lot of extra people, and so our managed service offering is custom built really to address those needs and really act as an extension of a lot of the IT departments of our customers. As I mentioned, education is core and central to what we do. As a matter of fact, it was one of the reasons that the company was founded. And so we like to feel that we really understand some of the challenges you go through, some of the places you want to get, everything from, that in-classroom learning to the residential networks, to guest access, to public venues. These are all the challenges that don't look and feel alike, but can be, solved by understanding, how the different parts and pieces of our offering might fit in a dorm room as opposed to a classroom or a gymnasium or an outdoor football stadium, or even, parts of your transportation apparatus. And last but not least, certainly the managed service component that I spoke to. We can do a deeper dive. Please feel free to reach out to me. I'll provide my contact information. But far and away, this is the most flexible an adaptable part of what we do, meaning there is no one size that fits all when it comes to managed services. Sometimes we deploy managed services simply to backfill positions that you can't find the right talent for, to helping you grow or scale faster, or even to offload, that day-to-day management of essentially what is that network plumbing, right? Those, those components of the network infrastructure that frees up a lot of our clients to focus on the applications and the endpoints and the environment. So with that said, I'm going to turn it over to Brooke Moore, and he's going to tell you a little bit more about Extreme and how they fit into this overall equation.
Hello, everyone. My name is Brooke Moore. I am the Senior Network Solutions Engineer for Extreme Networks in the Central Region. So I'm going to do a quick overview of our Campus Fabric solution. And to start it off, first off, I want to introduce you to, it's a quick video that I want to go through, and this video is going to be like an overview, and then we'll head a little bit into what the video talks about and why it focuses on these items.
From smart sensors to advanced robotics, facial recognition, augmented and virtual reality, technology and IoT are having a profound effect on your business. But is your network keeping up? Built node by node, application by application, protocol layered on top of protocol. It's the way it's always been done, but it's not working anymore. That's why we created Extreme Fabric Connect, a new simplified way to design, build, and manage networks. Based on enhanced shortest path bridging, Fabric Connect is the industry's most efficient networking technology, advancing networks by making them more flexible, automated, and secure. Rather than layering protocols, Fabric Connect simplifies the network by using a single advanced control plane for all of your routing, switching, multicast, and segmented traffic. With just one protocol, the network is simpler to design, operate, and troubleshoot. Recoveries are sub-second, so users don't even notice. Forget about the days of color-coded ports, manual configuration, and off-hours maintenance windows. Instead, services become elastic, extending and retracting on demand as devices connect and disconnect from the network. Strengthen your security posture by saying goodbye to flat IP networks. Deploy fully isolated network segments with ease and at scale to protect your critical information from the threat of an attack. For whatever innovative technology your business demands, you need a network that can support it. Join the thousands of Extreme Fabric Connect customers that have enhanced their users' experience. Amazing things are possible with the right combination of elements. To learn more about Extreme Fabric Connect, visit us at www.extremenetworks.com.
So as the video was talking about, right? So today, technology that's in the hands of our users is way surpassed what we've got in traditional network infrastructure. Smartphones, artificial intelligence, connected devices. I mean, refrigerators and dryers and washing machines are connected to the network now. It's getting unbelievable, everything that we're connecting in. And the traditional infrastructure is using those data protocols that can't continue to evolve as quickly as this newer technology is. And if you look at some of the root issue here, right? So spanning tree, 1992, it was invented to stop loops from happening. Yet a lot of networks today use spanning tree to provide a loop network so that I can have redundancy. That's not what its use case was for. OSPF back in 1991 for our interior gateway routing protocols, BGP in 95, multicast in 86. These are all antiquated technologies that we're still utilizing today. Shortest path bridging was ratified in 2012. It's both an IEEE and an RFC IETF standard. And it was actually, if you look at the IEEE standard, it decrements spanning tree. It's the replacement protocol for spanning tree when you look at the heart of what shortest path bridging is doing. And its origins go back to the provider space with MPLS-like functionality, but a lot simpler, a lot easier to use than the MPLS technology, which you do see also in a lot of enterprises and higher education solutions. So what is Fabric? Well, it's a virtualization technology that virtualizes our network and infrastructure. One of the biggest problems with the traditional networking is on an Ethernet plane, nobody knows the state of where things are, where they're going, and what's happening. It's a broadcast. It's a spray and pray technology where I'm sending out a massive broadcast to find out where somebody lives so I can send a packet to them, but I'm still spraying that packet out there. With a Fabric environment, I now have stateful understanding of where the packet is coming from and where it needs to go, and I send it down a single path. So I'm not spreading it across my entire layer 2 infrastructure. I'm being very dedicated on what's happening. So the data plane is the Ethernet switch paths. It's these ISIDs that we talk about within our Fabric environment. An ISID is an internal service identifier. You can simulate it somewhat with what a VLAN is, but an ISID, I have over 16 million ISIDs that I can identify within a Fabric environment. That allows me to segment my network very granularly and protect it from being hacked. So I can have my entire HVAC system on its own segmentation. And if that gets hacked because some of that technology is not completely up to date, it's open to people breaking into it, I contain it within that environment. It doesn't spread throughout the network. And ISIS is used as that L2 and L3 control plane. So ISIS is an interior gateway routing protocol that's extensible. And by extensible, I mean that I can route on layer 2, I can route on layer 3, I can make routing decisions on layer 4, and I can actually route IPv4 and IPv6 with the same instance of ISIS. So it's a very powerful routing protocol that actually came out about the same time as OSPF. However, it was much more memory utilized than OSPF was. So OSPF became the play because memory was very expensive back in the late 80s and early 90s. And so the power also with Fabric is, remember I said spanning tree was meant to prevent loops. It wasn't meant to build a redundant infrastructure. Well, ISIS builds a loop-free topology, but it still utilizes all of the networking connections. So I'm not creating this massive MSTP environment so that I can use these connections I have and not just have them sitting still. It utilizes those without that complexity that MSTP brings into play. So I mentioned simplicity, right? And the video talked about this. We've got spanning tree on top of that. We've got VLANs, then our interior gateway routing protocol, OSPF. We've got multicast. We've got PIM sitting on top of that, possibly BGP or MPLS. All of these stack on top of each other. If spanning tree needs to reconverge because a new route bridge comes on board or there was a miscommunication and it dropped BPDUs, everything above that has to reconverge. And now I'm talking about downtime. Now the network needs to reconverge, needs to refigure everything out. My VLANs need to come stable again once STP lands. OSPF needs to rerun Dijkstra so that it can figure out where my routing goes. It can become multiple 30, 60, 90 seconds of downtime. And if I'm on a call, if I'm on a video call like this, it's gone, right? I have to reconnect that. With Extreme Fabric Connect, shortest path bridging, we have one protocol. ISIS is routing everything. It knows where everything is. When there's a break, there's an immediate failover. ISIS knows its primary path, it knows its secondary, and it knows its tertiary path right now. So when there's a failure, it immediately fails over sub 200 millisecond and over 2,000 nodes. So very quickly, and you don't lose that call, you don't lose that video conference, it continues to pass the traffic. So, and then we talk about faster time to service. The status quo today, hop by hop provisioning. If I've got a new VLAN that needs to traverse the network, I need to hit every single point in that network that VLAN needs to hop across. And then, like I said, if you're utilizing an environment like you see in the left with multiple connections between different switches, now I have to use MSTP to prune and define which paths that VLAN is going to take. In a Fabric environment on the right, I simply program the interface that the camera plugs into. I program the interface that the video surveillance server plugs into. The network determines the path that traffic is going to take. I don't touch anything in between those two switches. It's automated provisioning because of the ISIS layer 2 routing protocols. So these are some experience, some market research that's been done. 11 times faster to go live on a new location. So you can program, configure, and get your network up 11 times faster than traditional infrastructure. Configurations are much simpler. They're much smaller. If you look at a traditional, what we call a backbone core bridge or a core switch that's running the Campus Fabric solution, you're looking at about 20 lines of code for the entire switch. It's very slim and it's very quick. Camera downtimes up to 2,000 plus times faster, and zero touch core, so zero errors. And nobody's ever fat fingered a configuration, right? I've done it plenty of times. I've brought networks down because I configured the wrong VLAN for the wrong interface or the wrong OSPF instance. And believe me, that it's heart-wrenching. And when you're in an environment where you could program the edge interface and then go to the other side and program that other edge interface. If you program it wrong, the only thing you brought down was that new service you're bringing on board. You didn't touch anything else in the network that's happening, which is very relieving on my side that I can do that. And I could do that at lunch. I don't have to wait till midnight or 1 a.m. to try to do these things. So simplified way to design, right? We're going to reduce your operational costs because we can design these faster, we can deploy these faster. Agility, I can add and move and redesign my network on the fly. I don't have to bring everything down to do any of this. And with that, I'm improving stability and the security of the segmentation, right? Because I'm able to identify specific objects I want in specific ISIDs, or that internal service identifier. And I can prune those out and leave those segmented so they're not communicating with other devices within my infrastructure, enhancing my security there. So why should I care? What's the value of my network infrastructure or my fabric solution? Like I said, the agility, increasing your weaker security postures, IoT traffic isolation. This is something that's just been blowing up in all of the education spaces that I've been walking into and working with. And multicast performance. I'm seeing multicast drive higher, not because you're using it in a traditional environment, because now I've got camera systems that I have to deploy, and most of these camera solutions require multicast capabilities. And then I have my my VMware solutions where I have to have multicast for VXLAN. So all of these things brought together really improves the capabilities and the enhancements and the possibilities that you can do with a campus fabric solution. So some of the network agility questions, right? Delay when rolling out applications or doing network changes. Well, obviously that's everybody runs into that. How frequent are those maintenance windows? How big do those maintenance windows have to be? How long does it take me to plan that fallback strategy when I'm configuring a new solution and I've got to have a fallback in case something doesn't happen? You don't have to do that in the Fabric Connect solution. Like I said, edge only provisioning, edge auto attach, and service elasticity allows me to move services around the network and they automatically come up where I'm plugging that new device in another site. So it gives you a lot of power, it gives you a lot of extra time to do the things with the network that you've always wanted to do, but you spend all of your time keeping the lights blinking the way that they're supposed to blink. And like it says here, ability to be more responsive to the business and to focus on, like I said, keeping the lights on. That's no longer a primary focus because the network does that for you. Security postures, right? Segmentation at scale. Like I said, over 16 million ISIDs, those internal service identifiers that I can identify. I hope you don't use all 16 million because that could be somewhat complex, but you can segmentation with ease. It gives me a lot more capabilities. I can segment within the same VLAN. I can segment out pieces that I don't want to talk to others. So I don't have to go in there and configure firewalls between these pieces because I want that segmentation out there. It takes that firewall piece out of it. And the communication path within the fabric environment is from point A to point B within the network. So my point of entry to my point of exit, where I do those definitions, that is where the communication path goes. It doesn't spread throughout the entire infrastructure. And that's why they tend to call it stealth networking topology. So use case example here. So we've got the downtown Grand in Las Vegas that needed to put in a new networking infrastructure. Traditionally in the Las Vegas environment, and I like to use casinos because of this fact, they have a front office, they have a back office, they have the IP surveillance, they have hoteling, they have the gaming floors. All of these had to have a physically separate network infrastructure. Extreme Networks is the first and only converged surveillance network to be approved by the Gaming Control Board of Las Vegas. That means that we have one physical infrastructure within the Grand Casino that separates all of these because of our security capabilities and our segmentation capabilities. There's no VLANs within the fabric infrastructure of a campus fabric solution. So there's no VLAN hopping, there's no IP addresses, so there's no hacking ability. Extreme has held several hackathons where we've offered $50,000 and $70,000 to someone who can hack into our infrastructure, and it hasn't been done yet. And I believe we're at 5 or 6 of those that we've hosted. No one's been able to do that. And then high performance multicast is a huge thing in the casinos because, believe me, these guys have a lot of video cameras in display. And usually they'd have to prune those out and have several rendezvous points, several PIM-SM servers sitting out there. And it became very cumbersome to try and maintain and manage that. Whereas in the campus fabric solution and shortest path bridging, that's not required any longer. No rendezvous points, no PIM-SM. It does it without it. It does it inherently. Then we look at City of Memphis, right? So again, they needed more network automation, and with Fabric Connect, we could do that. They needed to be able to easily segment IoT devices from critical city services. They needed to be able to separate the firehouse from the police department, from from City Hall. So they were able to do all of this because of the capabilities and the security of the campus fabric solution of shortest path bridging. So the multicast performance, it's simple. It's actually one command on each switch enables multicast in the solution. It's scalable to the point of we've had over 2,500 cameras sitting on a single campus fabric solution, and it was using less than 10% CPU. So it doesn't require CPU utilization to run a multicast, which is typically the case. You hit hard into the CPU, you hit hard into the memory. Because of the way that SPV runs, that's not a requirement any longer. It's resilient. It fails over instantly. We've done presentations before where we've had multicast streaming, and this is live. We have multicast streaming. We pull the network, and you don't see a glitch in the video that's coming across because it instantly fails over to the other path that it has sitting and ready to go. So some additional resources that we have for Extreme is we have the Extreme certifications that you can go through. ESS switching focuses on all of our switching architecture. The campus fabric solutions focus directly on campus fabric. So you can go through these. These are, you log into our dojo and you can go through these classes. And then we also have a lot of resources out on YouTube where you could do, technical intros. This is just an overview. Some of those that Ed Kohler does, he's one of our principal engineers. He will dig deep down into what each packet is doing and why we do it this way and how it works. And they're really great videos, typically in the 20 to 30 minute range, so not huge resource taxing for you to take time out and watch a 2-hour video. They're nice and short, but they're nice and detailed as well. I encourage you to go out there and take a look at those. So that brings me to my Q&A. I'll have to say one question that I traditionally get is, in a campus fabric environment where I'm in a traditional network now, so everything has to be fabric before I can do anything. That's not true. We can actually implement a solution that does both campus fabric and traditional and let you migrate slowly into a full campus fabric solution. It doesn't have to be core to edge. It can be, but it doesn't have to be. It can be core to distribution. It could be just core. If you have 3 switches, we can put a campus fabric solution in there and show advantages with just using those 3 switches. And that's all I have.
All right, thanks, Brooke. Are you able to see my slides now?
Yes.
All right, very good. So thank you for that, Brooke. This is Ben Jenkins with Cradlepoint, and I'm going to talk about how we fit into the campus fabric picture. And before I dive into that, I'd just like to introduce who Cradlepoint is and what we do. And let me get to my window so I can hit my slide. There we go. So Cradlepoint is the worldwide leader in wireless WAN for business. So we make a whole portfolio of products that can leverage the cellular broadband for internet connectivity. Way back in 2006, we knew that cellular broadband would be used for more than just getting your email on your phone, that it would be used for connecting your IoT devices, your vehicles, and your fixed locations. And now that 5G is maturing and being widely deployed across the United States and globally, we are certainly poised to be able to be a key player in your campus connectivity picture. So why are Extreme and Cradlepoint great partners for higher education, universities, and colleges? So as you just heard Brooke go over, Extreme is the leader in enterprise campus networking, and their fabric technology provides a unique value proposition for security and ease of connectivity for your campus LANs. Cradlepoint is the worldwide leader in cellular broadband access for business, and really this complements Extreme's portfolio by providing another way to connect your locations to the internet, not just using wired mediums such as DSL or cable or fiber, but also cellular broadband, particularly with 5G, now is a viable connection option. And in my point of view, 5G will be the last mile going forward as we look forward into the future. So what is unique about our pairing is that you can certainly deploy Fabric with Extreme on Extreme equipment. And what we bring to the table is we're able to allow you to leverage that Extreme Fabric networking over cellular broadband as well. So if you do have remote sites where you need to have quick day one connectivity, as we'll see in a few minutes, to get something up quickly, or as 5G becomes more predominant, maybe you want to have that as your primary connectivity method. You can rest assured that you can extend your Extreme Fabric network over the cellular broadband over the carriers through Cradlepoint devices into your campus, remote, and temporary locations. And then on top of that, Cradlepoint with our entire portfolio of devices for IoT and other use cases complement the branch solutions and the campus solutions with connectivity for those devices as well. And as Brooke was mentioning throughout his presentation, surveillance and multicast is a big component of those solutions, and that's certainly a big area where Cradlepoint plays as well, in addition to connectivity for digital signage, point of sale devices, and as Brooke mentioned, having a parallel or secure network for IoT is very much a required architecture due to the limited security capabilities of those IoT devices out there. So campuses are using Cradlepoint to provide bandwidth augmentation for their locations as a link diversity play, as a parallel network play to isolate networks for things like IoT devices, or just to have intelligent hybrid WAN connectivity, so where maybe you already have an existing wired broadband connection via fiber or some other physical wire medium, but would like cellular broadband as a backup connectivity mechanism, because let's face it, squirrels can't chew through cellular airwaves yet. So that's where we are really being deployed and provide value for the campus environment, so that your locations have that always-on internet, that you are able to provide a consistent WAN capability for your user experience. And sometimes, it's just impossible to get that wire out to a new location in a timely fashion. So, you're typically looking at 30 to 60 to 90 days for a new wired internet connection to a location, whereas you can literally deploy a cellular broadband connection in a matter of hours. So we give you that flexibility to pop things up very quickly, and continue to use that as either a primary or backup connection. So tying back to how we integrate with the Extreme Fabric solution, just to touch on some of the terminology that Brooke was mentioning during his Fabric solution portion. So here we've got the Cradlepoint router providing both wired WAN connectivity as well as cellular broadband connectivity. And we participate in the Fabric Extend capacity for Extreme's Fabric solution. So you've got an Extreme switch there on the left that is providing that Extreme Fabric. It's extending the Extreme Fabric over the cellular broadband through the Cradlepoint router to that remote location, to that campus facility location to the campus data center. And then things like the Extreme access points are actually using Fabric Attach, which is a slight variation on that to the Extreme switch. So this is a very seamless integration. It's been pre-tested with the Cradlepoint solution to provide Fabric extension over cellular broadband with Cradlepoint. Just to kind of blow this up a little bit, you've got, again, a Cradlepoint device. This would be your day one connectivity use case. So maybe you are standing up a new classroom, maybe you're moving classrooms, when you're bringing on a new student dormitory and have to get connectivity, and the wire connection isn't quite ready yet. You can deploy a Cradlepoint router with that 5G cellular broadband network on it very, very quickly, and have it extend the Extreme Fabric over that Cradlepoint cellular broadband connection into the LAN segment for that campus facility. And then if you choose to continue that could either continue to stay as a primary connection using cellular broadband as the primary connection for that fixed location, or that can move into a cellular backup role where it is deployed either as a single box solution with both wired and wireless cellular broadband into the Cradlepoint, or side by side with another provider's router to provide not just WAN diversity but also hardware diversity for that connection to your internet. So the value proposition of the joint solution, again, you're getting modernization for your campus with best-in-breed products for your campus networking solutions, as well as your Wi-Fi, and then Cradlepoint is now on our second, almost to be third generation of 5G products for access to cellular broadband, and for higher education. Segmentation and security is a crucial part of keeping that campus secure with all of the various departments and users and devices that are always coming onto your network. Extreme Fabric is a fantastic solution and that is complemented by the Cradlepoint solution that supports Fabric Extend.
Ben, we did have a question come through. Is the 5000 series the minimum requirement?
So for the Cradlepoint routers here we're talking about would be the E3000 and the E300 are the routers that would be participating as part of the Extreme Fabric solution. And both of these devices, E3000 and E300, support 5G as well as 4G LTE. And up here, we've just got the entire Cradlepoint portfolio for fixed locations, for in-vehicle, for work from anywhere, and for our IoT portfolio as well. So that's all I have got for my content, and I guess we can move into back to Gary.
Thanks. Appreciate that, gentlemen. That was fantastic. Actually, I'm going to throw it over to Katie. I'll throw up my contact information as promised. And Katie, what's in the mailbag?
We have 2 more questions that came. Give me 1 second. First question is, will 5G replace Wi-Fi?
All right, let me jump on. There we go. So no, 5G is going to be a complement to Wi-Fi. They certainly have different use cases, different sets of devices that connect to cellular versus Wi-Fi, and we foresee them working hand in hand and complement each other well into the foreseeable future, just as Wi-Fi has complemented and extend to places that wired networking can reach.
Yeah, I would agree with that. And that's one of the reasons that we have, dedicated a practice in each of those areas, both from a 4 and a 5G as well as a traditional wired and a wireless or Wi-Fi practice as well. As we look at it as there's not, one tool to solve a problem. It's a collaboration of solutions that really achieve, that end state that everyone's looking for.
And the question there on the 5,000, the user said it was for the Extreme switch. So the 5,000 series switches within Extreme are universal. So they'll run the traditional Extreme operating system, or what we call now switch engine, or they will run the Fabric engine, which used to be called VOS, the virtual operating system. So they will run either one. But there were models previous to the 5,000 series that could run it as well. The VSP, anything VSP, the 4900s, the 7000s, the 72, 7400s, those also run Fabric. The nice thing about the Fabric solution, like I said, it could be your core and distribution, or core distribution and edge. You could have VSP or Fabric engine enabled switches in core and distribution, and traditional XOS switches or switch engine switches out on the edge connecting with Fabric attached, where they participate in the Fabric, they understand the Fabric, you still make the changes at the edge, they send that information into the Fabric configures it, but they don't actually run the SPV protocol. So you have those different solutions, they still work together, they're still very seamless and give you a nice Fabric complement there. But it's up to you. There are different capabilities within switch engine and Fabric engine when it comes to the edge, stacking being one of the biggest ones. Some people like to have stacking, so they will run switch engine out on the edge and do Fabric attach into the campus Fabric solution.
Awesome. Thank you, Brooke. And I think that clarified it for the customer as well. The other question that popped up was, what speeds are possible with 5G?
All right. Yeah, that's a great question. So 5G is a little bit different than 4G. When 4G first got spun up, it literally was like flipping a switch from 3G to 4G. You immediately saw huge increases in speeds between those two technologies. 5G actually has 3 different layers to it. One is called the coverage layer, the one's called the capacity, and then there's a high capacity layer as well. Each of those 3 different layers has different trade-offs between propagation and speed. If you've got the 5G icon on your cell phone, you probably really didn't notice much of a speed increase from LTE, and that's because the coverage layer is just an incremental like half step up from LTE speeds. What's really exciting now is that the carriers are deploying the mid-band, or C-band you might hear it referred to, and this is where we really start seeing cellular broadband speeds become comparable to everything except for fiber in terms of speed and capacity. So I've personally seen where we've got C-band coverage personally seen 800 megabits per second down and about 200 megabits per second up. Theoretically, we can see over a gigabit per second down with C-band. And then if we're talking about high band, which is the millimeter wave, we would be able to see 2 gigs a second or more of download speeds, where the millimeter wave high band capacity is available from the carriers.
Fabulous. Thank you for answering that. Those are all the questions that I've seen roll through. Brooke, Gary, if anybody wants to elaborate on anything else here, the stage is yours.
All right. Well, as promised, we said we would provide copies of the presentations as well as a recording of the entire presentation, and so we will send that out. And I thank everyone and appreciate your all's attendance. Please feel free to reach out with any questions or to further discussion.
Yes, thank you, everyone.
Thank you all.